In this video, we're going to be looking at turning two examples of digital images, JPEGs or rasters or bitmaps, whatever you want to call them, and turning them into machine-ready vectors for digital fabrication. Our first example here is a very low-resolution image, but because the contrast is so vivid between the black and the white, it's actually going to make for a very clean vector extraction. So I just found this image, so I'm just going to copy it and bring it into Inkscape, paste it in the work plane here. And it's quite small, so now it's going to become a vector, which means I can scale it without losing any quality. Inherently, that's the way vectors work. However, just for the sake of for argument, I'm going to make this a little bit larger. But if I do this sort of naively or without thinking, then when I drag the handles here, you'll see that it can become skewed and stretched in a way that I don't want. So to prevent this, and rather than just kind of guesstimating, oh, is that the way it was, I'm going to hold the Control key on the keyboard and then drag these handles, and you'll notice that no matter how I distort the mouse, it's going to maintain proportion. It's a very good tip to know when using software like this. Sometimes it's Shift, sometimes it's Control. It really depends on the program, but in Inkscape it appears to be Control. I'm going to turn this into a vector. Right now it's a bitmap, which is a series of pixels with color information, and I'm going to turn it into a vector, which is a series of paths defined by individual nodes, little points by which the computer can generate geometry to connect those nodes with curves and lines. Long story short, I'm going to right-click the image and select Trace Bitmap. And I have many different options of ways to trace it. I found trial and error to be the best way to sort of figure out, how's it going to look, because you can use this update feature to kind of see what the extracted vectors will look like. So if I do a brightness cutoff, I'll get that. Looks pretty good, honestly. It looks the same. If I do edge detection, I'm going to get something like this. And again, depending on what you want stylistically, this is sort of where you play around with these options and these settings until you get the final result. So I'm going to hit the OK button to sort of say, hey, yeah, this is what I want to do. I'm going to execute the trace. And at first it looks like not much happened over here. But if I close the trace window and I drag one of the images off, you'll see that there's actually two images. One, the original bitmap, and second, the extracted vectors. And it's hard to tell which one's which until I go to node editing, which is right here on the left-hand sidebar. And you'll see that this image has all of those nodes, which incidentally, if I were to distort, I can distort the image by modifying the path, which in this case I don't want, but I was just showing you how vectors work. So the bitmap is now no longer needed, so I'm going to go ahead and delete that. It's the vector that I want to work with because it's machine readable. Now you might think, well, this is ready to go, because if you imagine cutting this out of vinyl, then the black portion would be the color of vinyl that you choose, or if you're laser cutting it, then maybe you can get some nice wood grain and all these little black portions. But really this is a little bit misleading, because we want our machine paths to be visible so that when the machine cuts along those paths, we can remove the waste material and be left with what's black currently. All of which is to say, let's make this even more of an outline than it currently is. So if I go down here to the bottom left, I'm going to double click this section that says Fill and Stroke. That lets me change the color or lack of color for both the outline and the inside filling. In this case, you'll notice it says there's no stroke or no outline, and the filling is black. So what we're looking at is the inner portion, whereas what we want is the outline. So if I double click that section, it gives me some more options over here on the right hand side. For fill, I'm going to, I could choose different colors, but I actually want no color at all for the fill. And because there's also no outline, it's going to disappear for a moment. And I want my stroke to be visible. This is the outline. The cutting head will actually travel along, whether it's a laser or a blade or a router bit. So now you can imagine that if this is cut out along these lines using subtractive digital fabrication tools, then the end result is going to be the positive space that you actually want to keep. So this is a better representation of what the final product would look like in terms of the way that the machine would actually operate. So once it's to your satisfaction, all you really got to do is go to File and Save As. SVG is the native file format for Inkscape, and it's usually a good bet for most programs. However, some of our machine softwares have been a little bit picky about what they take, so it might be a good idea to save it both as an SVG as well as a PDF, just so you have multiple versions of it to sort of import rather than having to go back and doing it all over again. So save it as an SVG, save it as a PDF, which can also contain vectors in it. That'll just make it a little bit more foolproof to avoid having to redo the entire job. And once your file is ready as a vector, it's ready for import into the machine.